Alright, hello everybody. Here's 9.6 homework help. We're going to do 1 through 4, and 6 through 16, and we'll do all these. Okay, so 1 through 4 says, determine which of the two acute angles has a given trigonometric ratio. The cosine of 4/5. So remember, you need adjacent over hypotenuse for 4/5. So something that's going to simplify to 4/5. If you look at the numbers that you have here, this is going to be 8 over 10 simplified, right? So I need the 8 and 10 to come to play. So I'm going to use this angle here, C. This is the adjacent, and this is the hypotenuse. So the cosine of C will give me my 4/5 ratio, or 8/10 ratio, which simplifies to 4/5. Alright, the sine angle is 5/11. So the sine is opposite over hypotenuse. So in order to be opposite, if I use angle A, opposite angle A is the number 5. So sine of A is 5, and then over the hypotenuse, which is 11. Cosine, I'm saying the sine of the angle is 0.96. Okay. So here we want, so to get the sine, you could play around with a couple of these. So you have a couple options here. You're going to have sine of something over 25, right? Because that's going to be the hypotenuse no matter what. Right, so you're going to use the hypotenuse. So it's either going to be 7 or 24. And if we can get an understanding of, having the sine of something be 0.96, what is that? So what fraction is going to be closer to 0.96, right? 7/25 or 24/25? Well, 7/25 is not 0.96, right? 24 over 25 is where you get your 0.96. So sine of, I'm going to use opposite sine of A is 24 over 25. Because 24 over 25 on the calculator is 0.96. Right, so you could do it that way as well. 1.5, okay? So if you're looking at these again, this one says tangent, so I'm not using the hypotenuse here, I'm only using the opposite over adjacent. So when I'm looking at tangent, I need to get 1.5, so is it 12 over 18 or 18 over 12? And you need 18 over 12 to get a 1.5, so the tangent of what is going to give you 18 over 12? Well, it's tangent's opposite over adjacent, so I need the 18 to be my numerator, because it's going to be the opposite, and the adjacent is going to be 12. 18 over 12 is equal to 1.5. Alright, and then we're going to look at, so we did 1 through 4, 6 through 16. This is just using, so let D be the acute angle, use technology to approximate D. So here on our calculator, we're just going to do sine inverse, let me erase that. We're going to do the sine inverse of 0.19 will give me an approximation of what angle D is. So on my calculator, I'm going to second sine, which is going to give me sine to the -1 power, but it's not a power, it's called sine inverse of 0.19. And this is going to give me about 11 degrees. Alright, and I'm going to do the same thing here. This time I'm going to do tan inverse of 0.72. Wait, so on my calculator, I skipped one. So just do this one real quick. Tan inverse of 0.72. And plug that into my calculator. This is going to be about 35.8. And I got one more here. It's going to be the cosine inverse. And this is all strictly on my calculator. 0.64. Which is about 50.2 degrees. Alright, so this is just straight calculator work there. Alright, solve the right triangles here. We have, we're going to do numbers 6 through 16, okay? So we're going to solve this right triangle here. Let me clear out some space here for myself. Okay, so if I'm looking at number 12 here, start with E. So if I'm looking at E, I can use opposite and adjacent. So the tangent of E is equal to 14 over 8. Okay, so that's the tangent of E. I need to make this little space. I'm going to put a little space here. Tangent of E is equal to 14 over 8. I'll show you why I'm making the space here. So what I need is I need this to read that E is equal to, or approximately equal to something. So in order to get rid of this tangent, I'm going to use the inverse tangent of the tangent. And the inverse tangent of the tangent is going to allow me to cross out the tangents and just write the E. That's the inverse, right? Like multiplication, division, addition, subtraction, right? They'll cancel each other out. So the inverse tangent will cancel out the tan. But what I do to one side, I need to do to the other side. So that means I'm going to take the inverse tangent of 14/8. So to get E, I'm going to take on my calculator the inverse tangent of 14/8 and get an approximation. So second inverse tan, 14 over 8. And this gives me an angle of about 60.23 degrees. Once I'm there, then I could get D. D is just going to be equal to 180 minus the 90 degrees that I know, plus the 60.25 that I just figured out. So 180 minus 90 minus 60.25. And that means angle D here is going to be 29.75 degrees. And ED, right, if I'm solving everything, ED, this is just a right triangle, so C squared equals A squared plus B squared. And I know that A is 8, B is 14, and then I'm going to take the square root of all that. So C equals the square root of 64 plus 196, which is 260. And I can simplify this. I'm going to divide this by 4. It's going to be 4 times 65. And the square root of 4 is 2. So 2 root 65. If I break down 65 again, I'm not going to get anywhere except for I'll get 5 times 13. Both of those numbers are prime, so I won't be able to go any further. All right, so that'll be the exact value here. All right, so that's number 12. All right, I'll do 14. I'll do 14 down here. So we have 14 and 16. I'm noticing that 16 is my hypotenuse. So if I'm using angle G or J, it doesn't matter. So if I go with G, then I'm going to use the adjacent over the hypotenuse. So that means the cosine of angle G is equal to 14 over 16. I want angle G, so I'm going to use the cosine inverse. I'm going to take the cosine inverse of both sides. The cosine inverse and the cosine will simplify or cancel each other out. And you're left with G equals to the cosine or inverse sine cosine of 14/16. That goes right into my calculator. Cosine inverse of 14 divided by 16, and that gives me about 29 degrees. Okay, so perfect. So now I just have G is going to be 29 degrees here, which means that J is going to be 61 degrees, right? That's just going to be 90 minus 29, right? Because this is already 90, so all three make 180. 180 minus 90 is 90, and then 90 minus 29 is 61. Okay, that includes that. And then I'm using my Staggering Theorem again. A squared plus b squared equals c squared. I have a squared. I don't have b squared, but I have c squared. And let's see, I have b squared equals 16 squared minus 14 squared. I'll take care of those in a second. So b is equal to the square root of 16 squared, 56 minus 196. So this is going to be the square root of 60. And b is equal to, again, this is going to be 4 times 15, 60. So b is equal to, square root of 4 is 2 radical 15. Okay, and then you have all the components here. Alright, last one, number 16. I'll do this one in green. So 16 I have the angle, cool. So I have 57. I have the opposite, and I need the adjacent, and I need the hypotenuse. So I'm going to do this two ways. Right? So if I want to get the adjacent, then I can use the tangent. So I'll go here. So the tangent of 57 degrees is equal to 15 over, and I'll just call this x for now. So that means, so remember from our last video, this can easily be rewritten as x is equal to 15 over the tangent of 57, right? So I'm just swapping the numerators, numerator to the denominator, right? And again, you can go through the algebra behind that if you want, and you would multiply both sides by x, and then divide both sides by tangent 57, and you get there. So I'll get that one. So 15 divided by tangent of 57 degrees, we got about 9.7. So x is 9.7. And now I could get RT by just doing 9.7. So we got a squared plus b squared equals c squared. So 9.7 squared plus 15 squared equals c squared. Square root all that. And that's going to be 15 squared plus 9.7 squared. That's not going to be anything nice. And that gives me 319.09 and the square root of all that. And this is one I would not even try to simplify. It's already in decimals, already estimated, so I'm going to say this is equal to, approximately equal to 17.9. So there's 17.9. And then you have nothing but angle T here, and this is really just going to be 90 minus 57, 40, 33. So angle T would be 33 degrees. Okay. That's 2 to 16. Then we have number 20. Cool, I got a little space here for number 20. I'll go on top here. So you are standing on a footbridge. Here you are. That is 12 feet above the lake. Cool. You look down and see a duck in the water. What is the angle of elevation from the duck to where you're standing? Okay, so I'm just going to see this here. This is 12. This is 7. And this is your sight. And you're looking for this angle here. I'll call this A. So there's my right, opposite, adjacent. Tangent of A is equal to opposite over adjacent. Okay, the math behind this is I'm going to take the inverse tangent of the left side, and I'm going to take the inverse tangent of the right side. The inverse tan and tan will simplify, and you're left with A, which is exactly what you want. It's going to be an approximation, and then this is what you're going to plug into your calculator. So inverse tan of 7/12, and you're approximately looking at an angle of 30.3 degrees. It's 256, blah, 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 but I'm going to round to the tenths here. So about 30.3 degrees is your angle, is the angle of, that he's looking at. Alright, so that's number 21. Number 21, this is a really good problem that people face every day, looking at a bridge and looking at a duck and figuring out your angle may not be. But 21, this problem is definitely something that's used on a daily basis. Okay, so the horizontal part of the step is called the tread. All right, true, and you can actually measure your own tread at home. And the vertical part is called the riser, and these have to be a certain size, otherwise the town or city hall or your building inspectors will say, no, you can't have those stairs. So there is a recommended ratio, as they say, 7 inches to 11 inches is pretty accurate. All right, so that means your step has to be about 7 inches high, and the tread has to be about 11 inches wide. Okay, so that way you have a good footstep to put here, and you're not, if your step's too big, then it's going to be hard to go up. If your step's too small, it's very, you might trip or something. If the riser is too small, you might trip. So on average, 7 to 11 is pretty average. So it says find the value of x from stairs the stairs built using the recommended ratio. So if this is my triangle, I'm finding the value of x here, where x is down here. So I have this tread here. Okay. And I need, so this is, so I'm not going to use the whole triangle, I'm just going to use this part here. This part still, so if I'm just going to draw that triangle here, that smaller triangle, because it's going to be similar. So if this is x, this bottom part here is my tread, so it's 11. This top part here is my riser, and the angle here. And the steps go on forever, never, never. But once I have the first step, then it's going to be the same angle. All right. So to get this angle x, I have the opposite and the adjacent. So the tangent of x is equal to the opposite over adjacent. Now I just need the angle. So this is where again I use the inverse tan, and I'm going to take that inverse tan of the left side, and I'm going to take the inverse tan of the right side, and the tangents will simplify, and x will equal the inverse tangent of 7/11. My handy dandy calculator, 7 divided by 11, and x is approximately equal to 32.5 degrees. Alright, and you want to build stairs that are less steep than the stairs in part A. Give an example of riser to tread ratio. Okay, so less steep meaning your angle's got to be decreasing here. So less steep would be here. So if this is 32 degrees, let's say maybe you want to make this 25 degrees. Okay, so then opposite over adjacent. So the tangent of 25 degrees is equal to, let's see, tan of 25 is equal to about 0.46. I'm going to round this to the tenths and say about 0.46, so 0.5. So that means your ratio has to be, which is equal to 1/2. So your ratio has to be a 1-to-2 ratio. So this is going to be 1 to 2, or x to 2x. So let's say you want your step here to be, your riser to be, I don't know, it was 7 inches before. Let's just say you want it less than that. Let's say you want 6 inches. Then this would be 2 times 6, which would be 12. So your riser would be 6 inches, and your tread would be 12 inches. So, and that would be less deep, and maybe easier to go up. It might feel a little different, but just one possible answer. All right, let's keep it moving. We got 23. Solve each triangle. Okay, so we're trying to get everything we need from this triangle. So, all right. So the first angle here is very easy. So I got angle. So I'm gonna look at this angle here. So angle. This is number 23. Angle J, K, M. Right. Here's 90. Here's 41, 45, and 4. 49 degrees. Okay, so 41 and 49 make 90. Okay, so these two angles are missing, so I still need angle MKL, and I still need angle MKL and KLM. Okay, so I still need those. And then I need a distance of JK. Right, that's missing. I'll call that X. I need the distance of ML. I'll call that Y for now. Okay, so let's get to it. So we got this one. We got this is 49 degrees. Right, so that one's done. And let's get this one. So I have the hypotenuse here. I have an angle, 41 degrees. I could use opposite and hypotenuse, so I could use sine to get K. So I could use sine of 41 degrees equals my opposite. We'll call this, actually, hold on, sorry. We don't have the opposite. We need that one too, actually. So we need Km as well. Okay, so this angle here, we said was 49. Put that out there. Okay, so I have this 41 degree angle. I have the adjacent, and I don't have the hypotenuse. So I could do cosine of 41 degrees is adjacent over hypotenuse. So we can use that. Right, so I have the adjacent side, and again, this is just going to be x is equal to 9 over cosine of 41 degrees. Plug that into my calculator. 9 divided by cosine of 41. And that gives me about 0.6. I'm going to round everything to the tenths. So this is 0.6. So JK. Oh, just joking. That's not that. That's 9 divided by cosine 41. That's definitely seems a little funny. And this is actually not 0.6, but this is 11.9. Rounding to the tenths. So now we have this one. Okay, that means Km. This is for JK. For Km, I'm going to use the Pythagorean Theorem here. So I'm going to say that 9 squared plus 11.9 squared is equal to c squared. Square root of all that. And I'm going to put pretty much the square root of 9 squared plus 11.9 squared on my calculator. Square root of 9 squared plus 11.9 squared. Ooh, a little mistake here. Sorry, guys. Backtrack a little bit if you caught that mistake. 11.9 is my hypotenuse, not my leg, so this is going to be, when I do a squared plus b squared equals c squared. To solve for one of these, let's just say I'm solving for a, this is going to be the square root of I have my c squared, I'm going to bring over my b squared, and then take the square root of both sides. So that's going to be 11.9 squared minus 9 squared is going to equal that missing side, square root of all that. And that's about equal to 7.8. So Km, 7.8. Now I can solve for ML, My, or ML, which is my y, because I have 7.8 and 21, so I'm going to use the same formula here. So for ML, I'm going to use the same thing here, that a is equal to the square root of c squared minus b squared. My hypotenuse here is 21, and this is my 7.8. That's about equal to 19.5. So I'm rounding all these, so there might be a little error in rounding. Okay, but more or less that's what it's going to be. Alright, and then the last piece here is I need, this is 49 in there. So I need these angles, I need one of these angles, so angle L or K I could use. If I use angle L, I could use the adjacent over the hypotenuse. So adjacent over hypotenuse is cosine, so cosine of L is equal to adjacent, 19.5, over hypotenuse. So again, to get rid of all this, I'm going to have to use the inverse cosine. So to get L, I'm going to do the inverse cosine of 19.5 over 21, and that'll give me the approximation of L, right? So I want to get rid of the cosine by taking the inverse cosine, and I'm going to take the inverse cosine of both sides. And this will give me what L is approximately equal to. So cosine inverse, 19.5 divided by 21, and I get 21.8-ish. So that's angle L here, so KLM, 21.8, which means that MKL, 68.2. Because those two together must make 90. Alright, so that's number 23. Okay, 24. I have to clip this one and do it on the bottom. Okay, so this angle is easy, right? That's going to be 26 degrees, because 90 means these two must make 90, so 26 and 64 makes 90, so I'm done. That's easy enough. This is 4. Okay, so let's get UT. So I have 64, I have the adjacent side to 64, so I can use tangent to get the opposite side. So remember, so tangent of an angle, so I'm going to do the tangent of S is equal to opposite over adjacent. So the tangent of 64 is equal to opposite, so we don't know that one, over adjacent, which is 4. So I'm calling UT x. So x is equal to 4 times tangent 64. Easy enough. 4 tangent 64. That gives me x is equal to about 8.2. So we'll erase that. So this one's 8.2, which means now I can solve for ST if I wanted to. ST is going to be the hypotenuse of this, so 8.2 squared plus 4 squared equals c squared, square root of all that. So I'm calling this ST here my c. So the square root of 8.2 squared plus 4 squared equals about 9.1. So here to here, get rid of this. So from, I'll highlight this in red. So this piece is 9.1, and then we have the other piece here that's in blue, which is 5. So the whole thing from here to here is 14.1, so we can recognize that, which means then we could get WT. So 14.1 is the hypotenuse, PW is a leg, so this is where I'm going to use A equals the square root of c squared minus b squared. When you have a leg, use this formula. When you have 2 legs, then you can use this one. So the square root of, it's easy enough, 14.1 squared minus 9 squared. It's about equal to 10.9. Alright, and then lastly, get angle T or angle V, so whatever. I'll go angle T, opposite, and I'll use the hypotenuse here, so this will just be sine of T is equal to opposite over the hypotenuse, which is 14.1. I'm going to take the inverse sine of both sides. So I'll be left with T equals inverse sine of 9 over 14.1. That leaves you about 39.7. So this is 39.7 degrees, which means that this angle here is going to be 50.3, which comes from 90 minus 39.7. Alright, so that's numbers 23, 24. Alright, 25. We can do one of these, it's fine. Same concept. So 25 says find the angle. It's actually pretty cool. So if you have the graph of y equals 3x, right? Plus 0, so you're starting at the origin, and your slope is 3, so you're going 1, 2, 3. So rise 3, run 1. And I'm just going to redo this a little bit so it just makes it a little bigger. So rise 3, run 1. So when you create this, you're creating a triangle from here to there to there. So there's your triangle. And this is a 3 to 1. And what they're asking for is this angle here, and I'll call this A. So what is this missing angle here? So what do you have? You have opposite and adjacent. So tangent of angle A is equal to 3 over 1, opposite over adjacent, so, or just 3, but I want the angle, so I'll have to take the inverse tangent of A, or, sorry, inverse tangent of tan of A, and the inverse tangent of 3, these cancel out, and A is equal to tan inverse of 3, A approximately equals to 71.6 6 degrees rounding to the nearest tenths. So that angle is 71.6 degrees. So when you have an equation of y equals 3x and a linear equation, right, so there's my line there. That's why this is y equals 3x right here, right, going on forever. And I'm looking at this, what's the angle approximation here? So there's the coordinate 3, 1, or 1, 3. What's this angle? You're making a 71 degree angle, and this will go on forever. 71.6 degrees, roughly. Alright, 25, and I'll leave B for you guys. And then the last one is 29, I believe. The perimeter of a rectangle is 16. Okay, so let me make myself a little rectangle here. Let's see what we got here. The perimeter is 16. Width is 1 to 3 ratio. So this is 1 to 3. So I'll just say 1x to 3x. And so this will be 1x, 3x. So altogether I got 3x, 6x, 7x, 8x. So if I add those all up, I get 8x equals 16, the perimeter, right? So you just add these all up to get the perimeter. Divide by 8, and you get x is equal to 2. So that means this is 2, this is 2, this is 6, this is 6. Okay, cool. Then, what else we got here? So we have a diagonal cut here. So segment BD. So we have A, B, C, D. So BD divides the rectangle into 2 congruent triangles. Okay, cool. And so 2, 6. Find the side lengths and angle measures of the 2 triangles. Okay, so the side lengths, we got 2, 6. We got that, check. And the angle measures of the 2 triangles. So we need this angle and this angle. We know this is 90 already. So if we find this angle here, this is going to be opposite. We can find BD very easily, but we don't really need to. We can use the opposite and the adjacent. So the tangent of an angle. So tangent of angle ABD is equal to the opposite over the adjacent. So that means the inverse tangent. So angle ABD, we'll have to take the inverse tangent of 2/6 or 1/3. My calculator's dying here, but we'll try and get these last problem in. 2 divided by 6. And we got angle ABD is approximately equal to 18.4 degrees. So this one is 18.4. And then we have this angle here, which is just going to be 90 minus 18.4, which will give me 71.6 degrees. And that's it. Hope this helped. Enjoy.